Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is majority element second. We have done majority element, that was the easy problem, but this is medium marked. However, this is also really easy. So it says, given an integer array of size n, find all elements that appear more than n by 3 times. So n by 3 times, what does that mean? What is n? N is the size of the array. So tell me now, in order to find how many numbers have occurred in this more than 1/3 of the size of the array, so let's find out. First, how about, since it's all about calculating the frequencies of these numbers, and then find which number has the count more than 1/3 of the size of the array. So I will create a map. That map will give me the count of each number. So 3 occurred 3 times, 1 occurred 3 times, and 2 occurred once. Then I'm going to find out that x is basically 1/3 of the floor division of 1/3 of the nums size. So nums, and I'm going to just call it length, L nums, len nums divided by 3, take the floor division, and in our case it would be 7 divided by 3. That will give us, what is that going to give us? That is going to give us 2.33 and 33 so on. So, and that would be just 2, and that is because we're just taking the floor. This is the floor division. Okay, if it was ceiling division, then you will basically move this entire value to up. So ceil would be 3, but the floor is 2. So now we can just go through the values and the keys of map. So I just can simply just say for key and val in map.items, if this val is actually greater than my x, then I will have a result array and I will add it to my result. So result.add, then you can just add the key here. Okay, it's the number you're returning, and then finally just return your result. So that would be our entire solution. Now here, if you're finding your answer like this, then the time complexity of this solution would be big of n, and space complexity is also big of n because you are using this map. We are using this map. This is our entire solution, and this is a decent solution. It's one of the solution, but there are other solutions which can bring the space complexity to big of 1. They can bring the space complexity from big of n to big of 1. And another solution that is also sort the element, and then basically loop over the elements and then count how many elements are actually there that occurs more than 1/3 of the times. So that would basically take our time complexity to big of n log n, which is more than, of course, what we have right now. However, there is another solution which is Byron-Moore. You can definitely check it out. It's a decent solution. It just only brings the space complexity to big of n. However, Byron-Moore is a really nice solution when you're working with the majority element first problem, because that asks only of the element that occurs more than 1/2 times more. Okay, so let's code up this solution. It's gonna be quite easy. I'm gonna quickly create like num map. Simple. I'm not just gonna use counter. You can use counter, but like this is also pretty good. So for key for num in num map, not num map, nums, and in my num map for this particular num, I am just gonna increment its count if it already exists, otherwise assign it 1. So that's gonna be done like this. This get for this key, if nothing found, assign 0, otherwise whatever we found, increment by 1. Now we're gonna declare the result that is going to be at max 2 values, but we'll have to get through all the key and val in nummap, and if the val is actually greater than, and let me just calculate it just once, that is length of nums divided by 3, but this will give me a decimal division. That's what I don't want. But if I have this, I divided by using this symbol, that means I am dropping everything after the decimal. So this is giving me floor division. So I can just simply say if this value, the frequency is actually greater than x, then that is one of my numbers. So I will append it to my result. This number, I'm appending the key. And in the end, finally, I can just return this. So let's zoom out and hopefully it passes our test. In nummap.items, that's something that I always forget, but it's an easy mistake. Let's submit this. Okay, so it's not a bad solution, right? Not bad at all. So it's going to be of time complexity, because in terms of time complexity, I don't know if you're gonna do like any better than big of n, even if you do Bayer and Moore. But space you can definitely do better. Big of n, and space is also big of n. All right. So this was an easy problem. Let's mark this solved. See you guys later in the next problem. Until then, bye-bye.